Assalamualaikum and good day everyone. Today we are going to represent our 60 satellites. The core for global connectivity satellite communications are actively improving with the expanding of advanced mobile networks, especially 5G, B5G and 6G. For decades, satellite communication have been an integral part of global communication systems. As connectivity in remote areas can be provided, global navigation system can be supported, and a crucial role in broadcasting and telecommunication services can be well played. Satellite communications are expanding and upgraded, aligning with these introductions to new advanced mobile networks. And now a 6G satellite is in the making process globally to further increase the performance. Now we proceed with the differences between 5G and 6G. First of all, the data rate. For 5G, the data rate is up to 200 bits per second, while 6G is targeting up to 1 terabits per second. Thus, future 6G satellite can transmit much larger amount of data, enabling applications such as holographic communication and digital twins. Next is the latency. The latency for 5G is 1 millisecond, quite small already, but 6G is targeting sub-millisecond for the latency. Latency is significant when involving geostationary satellites due to the need of the signal to travel long distance. This improves real-time services such as autonomous transportation, remote healthcare, and industrial automation. Next is the frequency. 5G has the frequency of sub-6 GHz and millimeter wave, while 6G is aiming for the frequency of sub-terahertz and terahertz. Higher frequency means larger bandwidth is provided and higher communication capacity is achieved by the satellites. Other than that, in terms of connectivity, 5G connects devices, while 6G aims to connect the entire environment. The entire environment means our home, car, office, and even infrastructure around us. This allows seamless global coverage, including remote and underserved areas. Lastly, artificial intelligence. 5G is AI assisted, while 6G is AI native. This enables 6G satellites to autonomously manage resources, optimize communication links, and improve network efficiency. According to all of these aspects, it is expected that 6G satellite will expand global network coverage and strengthen network security while being economical.
Now I will explain on how 6G works. 6G, or the 6th generation of wireless communication, is expected to be deployed around 2030 and will provide much faster and smarter connectivity. The main objective of 6G are ultra-high data rates of up to 1 terabit per second, extremely low latency, high reliability, improved energy efficiency, enhanced security, and massive network capacity. The communication process starts when a user generates information. The transmitter converts this information into signals which are sent through a wireless channel. Finally, the receiver reconstructs the information and delivers the intended data to the user. This enables fast and seamless communication for the future technology. This slide explains the high-frequency spectrum used in 6G technology. Unlike previous generation, 6G is expected to operate in sub-terahertz and terahertz frequency bands, which provide much wider bandwidth and enable extremely fast data transmission rates. However, higher frequencies are more sensitive to noise and interference. To overcome these challenges, 6G uses advanced signal processing, AI-driven optimization, error correction techniques, and intelligent beamforming. In addition, quantum-secure technologies are expected to enhance security by protecting sensitive data and supporting safer communication networks. These innovations make high-speed and secure 6G communication possible. This diagram illustrates how 6G communication works. The process starts with data generation from users or smart devices. The data is then processed, encoded, and modulated before being transmitted through wireless channels. AI-based network management continuously optimizes network performance, while beamforming improves signal quality and coverage. 6G also integrates sensing and communication capabilities, allowing devices to collect and exchange information simultaneously. To protect sensitive data, quantum-secure protection is applied. Finally, the receiver demodulates the signal and delivers the information to the target application. These advanced technologies make 6G faster, more intelligent, and more secure than previous generation of wireless network.
I'm Nurul. I'm going to discuss about 6G challenges. When people talk about 6G, everyone gets excited for mind-blowing speeds up to 1 terabit per second. We are moving into ultra-high terahertz frequencies, but those speeds come with a massive physics wall. As wireless wavelengths shrink to fractions of a millimeter, they become incredibly fragile. The moisture and oxygen in the air literally choke the signal, causing it to completely die off after traveling just a few meters. It's an insanely fast network, but right now it struggles to even leave your room. That brings us to the next engineering bottleneck: power. Because terahertz signals decrease so incredibly fast, you have to blast them with massive energy just to make them travel a usable distance. But generating that continuous power is a hardware nightmare. 6G is meant to connect billions of tiny, low-power smart sensors across the Internet of Everything. A miniature device simply doesn't have the battery capacity or the cooling architecture to handle that much raw energy, creating a brutal power deficit we haven't solved. Finally, there is cost and complexity. Since these high-frequency signals are ultra-short-range, cities will need millions of tiny base stations packed tightly into every single block. On top of that, true global coverage requires fully integrating our ground networks with space. Launching and maintaining massive fleets of low Earth orbit satellites demands a staggering financial investment. Blending fast-moving space tech with everyday ground hardware is the most complex infrastructure project humanity has ever attempted.
Next is what the 6G satellite will achieve. The first one is global connectivity. The evolution of satellite communication beyond 5G aims to provide communication services in areas where terrestrial network cannot reach. Through the integration of satellite and terrestrial network, 6G is expected to deliver seamless internet and communication services across remote regions, oceans, mountains, and other undeserved locations. Regardless of the geographical location, global connectivity can be achieved. 6G satellites are also expected to enhance the network capacity and data handling. The advancement of satellite technology is driven by the growing demand for communication services worldwide. Future 6G satellite systems are expected to support larger traffic volumes and higher data transmission capabilities to accommodate increasing network demands. Next, it can improve network security and reliability. One of the key features of 6G satellite communication is the extensive use of low Earth orbit satellites. Since these satellites orbit closer to the Earth than traditional satellites, signals can travel shorter distance, resulting in lower latency and higher data transmission speeds. This can improve network architecture and communication processes, leading to faster and more efficient data transmission. And lastly, increased data transmission speeds and efficiency. 6G satellite system can function as backup communication networks when terrestrial networks become unavailable due to natural disaster, cyber attacks, or technical failures. Moreover, advanced routing and network management technologies enable the system to adapt to change in satellite position and network condition, thereby maintaining stable network performance and reliable data transmission. All in all, our 6G satellites are expected to expand the global coverage by integration of terrestrial satellite, which can enhance the worldwide connectivity and provide remote area access. Other than that, the network performance for our 6G satellite will increase data transmission speeds and network capacity while improving reliability. Next, more future applications can be improvised by 6G satellites such as Internet of Things, mobile broadband, and data navigation services. Lastly, the challenges such as security concern, network navigation complexity, and high deployment costs are expected in order to achieve the high performance of 6G satellite. Thank you.